Here are the solutions for day 4. Solve each equation. Some of the equations are exponential equations. For instance, question A involves an exponential. Question C involves an exponential. The others are called logarithmic equations. That would be this one and this one. Now, we could solve these on a calculator using the graphing capabilities of a calculator. We've used the calculator earlier this year to solve equations by looking for where a line intersects a curve. But we're not going to do that here. Let's solve these algebraically by using the idea that exponentials and logarithms are inverses. So question A, to get at the variable x, which is in the exponent, we need to remove the base e. So let's do the inverse operation of that. Take the natural log of both sides. Because the natural log of e to the x is x. And so we have x equals the natural log of 10, which can be evaluated on the calculator. If you round off an answer, it's 2.30. If you're looking for the exact answer, it's natural log of 10. Now question B, this time we have natural log of x. We want to get the x alone, which means we need to remove the natural log. So let's do the inverse of natural log. The inverse of natural log is an exponential with base e. So let's go e raised to that power on the left side and e raised to that power on the right side. This is called exponentiating. E to the natural log x makes x. And on the right side, we have e to the negative 3. If you want an exact answer, you can leave it like this, or you could type that in the calculator to get a decimal. It's 0.0497 if you round it off. So in question A, to solve an equation with an exponential, we did a logarithm on both sides. In question B, to solve an equation that had a logarithm, we exponentiated on both sides. Okay, question C, we want to solve for x, which is in an exponent. So we need to do a logarithm. So we're going to do the base 10 logarithm of the left side and take the base 10 logarithm of the right side. The base 10 log of 10 to the x is x. And on the right side, we could type that in the calculator. It's 1.62 if you round it. Question D. This time we have a logarithm, but written in two different terms. Let's condense that together. So log base 4 of x divided by x minus 1. Now we can remove the logarithm expression by doing its inverse. The inverse of a logarithm with base 4 is to exponentiate with base 4. So 4 raised to that power. And over here, let's go 4 raised to that power. This cancels away the logarithm, and it leaves the x over x minus 1. On this side, we have 4 to the 1/2 power, which is just 2. Okay, so we now have the equation x over x minus 1 equals 2. So we can multiply the x minus 1 over to the right side. So now we have 2x minus 2. We can then subtract the x over to the right side while adding 2 to the left side. And we'll have 2 is equal to x. We want to make sure that that's not a restricted value. So when you look at the original problem, is it okay to put a 2 in? Well, sure it is. 2 minus 1 does not make a 0 in the denominator, so getting an answer of 2 checks out.